Okay, so hello and welcome to my microeconomics lecture series. In this lecture slides, I'm talking about consumer preferences and consumer choice. So this is kind of our introduction to consumer theory. What I say here is these slides go beyond what you're ultimately responsible for. And remember, the reason for this is most textbooks, and indeed our textbook, doesn't go into great detail along these lines. And so I'm going to provide some of that background context. Ultimately, then what I do is I'm going to summarize what we actually need in 1 to 2 pages on the board during class. And at the end of this video, I'll switch over. So if you want to, it's really easy to find by skipping to the end of the video. You can see where these slides go away, and then there's obvious images of a blackboard. So anyway, all right. So the first thing to introduce is our budget constraint. And the basic idea with consumer theory is we are interested in determining what's going to be the optimal bundle of goods that a consumer is going to choose given the constraints of scarcity. And so in order to be able to build to the choice, the optimal choice that a consumer is going to want, we have to build a budget constraint first. We have to talk about their preferences. We'll talk about utility functions, and then that ultimately gives us the foundation we need to be able to talk about optimal choice. So here I'll begin talking about a budget constraint. So the first thing, we'll think about just a simple two-good economy. And you might think two goods is too simple, but it's actually not. I mean, you can do a lot of things with a two-good economy. You can actually model almost everything, albeit in a simple manner, simply by focusing on whichever good it is we care about. So it could be shoes, it could be, carrots, whatever it is, and everything else could be the other good, right? So you have like shoes is one good, and then everything else that you could possibly consume is the other good, and that way you could model kind of everything a consumer would purchase. Now, admittedly, you'd probably want to add additional goods, and indeed, our model here is robust to that. This is the simplest version. You could actually make a similar budget constraint with that's n-dimensional. So anyway, we don't need to worry about that. We're going to focus on a two-good economy. So suppose we have M dollars to spend. So this is the money available, the income available to spend on two goods, good one and good two. And we're going to call X1 and X2 the amount that the consumer buys of goods one and of good two. This is going to be the consumer's consumption bundle or a prospective consumption bundle. So an ordered pair X1, X2 is going to be an amount of good one and an amount of good two. And you can imagine this in sort of the XY plane. If what's usually X on the horizontal axis is what we're calling X1 or good one, and then what's usually Y or on the vertical axis is what we're calling X2. Right? So this is just going to be an ordinary XY plane, Cartesian plane. Okay. Anyway, so this is going to be a point in the Cartesian plane. Okay, so anyhow, this is the consumer's consumption bundle, and we're going to need some prices. So the prices are going to be P1 and P2, and it actually turns out what really matters is going to be the ratio of P1 to P2. The relative prices are what's going to matter for consumption choices. So anyhow, our consumer can afford all bundles such that it exhausts its budget or just fails to exhaust its budget. It can spend no more than the money it has available. How about that? So P1 X1 is the expenditure. This is the expenditure on good one, right? The price of good one times the amount you buy. And then this is the expenditure on good two, the price of good two times the amount you buy. And of course, the expenditure on good one plus the expenditure on good two cannot exceed, right? Cannot exceed, can be less than, but cannot exceed the amount of money you have available. So this is the consumer's budget constraint. Okay, and then graphically, right? So I was talking about the graph we could draw. Here is the good two axis. Here is the good one axis. And then we have our budget line, right? So it's just a downward sloping line. And its slope, as you might have guessed, and I'll develop this a little bit later on, is going to be the ratio of price of good one divided by the price of good two. These points are labeled. So M divided by P1, this is the amount of money you have available divided by the price of the good. That's how much you can buy. So M over P1 is an amount. That's the maximal amount of good one you could buy if you spend all your money on good one. This is the maximal amount of good two that you could buy if you spent all your money on good two and didn't buy any good one. And in between are all the bundles that you can just afford. That's the bundles lie on the budget line. Inside is the budget set. These are things that are affordable, but you're not exhausting your budget. This is a little bit like the production possibilities frontier. And then beyond the budget constraint are bundles that are not affordable. So you might like them, but you can't buy them. Okay, so the budget line, the budget constraint gives us the set of affordable bundles. And actually when I write this with the weak inequality, the less than or equal to, this is going to refer to actually all the bundles I can afford, not necessarily the ones that totally exhaust my budget. I say it's bounded by the budget line. The line, the actual line that we drew, the actual constraint itself, those are the bundles that are just affordable, where you exactly exhaust your budget, where there's no money left over. Right, so my comment, when the consumer chooses a bundle that's on the budget line, this exhausts their entire budget. They've spent all their money. There's no money left over to allocate to one good or the other, which means if you decide that you want more of good one or more of good two, you're going to have to face a trade-off, right? There's scarcity. Moving to another bundle requires a trade-off, much like moving between efficient bundles on the production possibilities frontier. And as you might suspect, that rate of trade-off is going to be governed by the price ratio. The price ratio, P1 divided by P2, is going to give us the rate at which the economy is going to allow, the market is going to allow the consumer to make that trade-off. Well, anyway, we haven't gotten there yet. I'll show this development. So here is our budget constraint. Here's the actual budget line. And we can just manipulate this. Let's solve this for x2, right? We put x2 on our vertical axis. So that's like our y. Let's get this thing in y equals mx plus b form. Right? It's a solve for y, essentially. Well, x2 is taking the place of y. So when we solve this thing for x2, well, we subtract the expenditure on good 1 from both sides. And then we're going to divide through by the price of good 2. And when we do that, we get m over p2 minus negative of the price ratio, p1 divided by p2 times x1. And then, like I say, yeah, written like this, it looks like an old friend. Looks like our y equals mx plus b, and here I wrote like y equals ax plus b. It's basically slope-intercept form of a linear equation. So here's the slope, and here's the intercept, m over p2. Let's check that. Sure enough, I said minus p1 over p2 is the slope, and m over p2 is the vertical intercept. Okay, cool. So anyhow, so return to an important point. Choosing between the bundles lying on the budget line requires a trade-off. As we said, if you're exhausting your budget and you want more of one good or the other, then you have to give up some of what you're currently consuming. The rate at which you're able to make this trade-off is governed by the price ratio, P1 divided by P2. And so now here what I'm doing in the slides, I'm talking about how we can develop this change algebraically. The basic idea, so let's not worry too much about the details. Basic ideas, I'm saying, suppose we're on the budget line and we decide we want more of, we want more of good 1, right? So we're going to move further to the right. If we're going to move to the right down the budget line, we're not getting any additional money. We have to give up some of good 2, right? So you're going to get whatever is my current consumption of good 1 plus some change in good 1 times its price, plus my current consumption of good 2 plus some change in good 2, this will be negative, right, times its price. And it has to add up to my total amount of money. Okay, so little bit of manipulation, clever manipulation, and basically we get this relationship. So, at this level, don't worry so much if you want to work through this math. If you actually want to subtract the original budget line and do that work, that's fun to do. I'll leave that as an exercise. It's not one that I expect you to do. Basically, if you do this, you'll get this relationship. Delta x2 divided by delta x1. So the change in good 2, in the amount of good 2 consumed, divided by the change in the amount of good 1 consumed is equal to the price ratio, right? Okay, so if you've taken calculus, you might recognize we can replace this delta with a d. So this is like dx2, dx1. This is just a derivative, right? And sure enough, the derivative of the line is just going to be its slope. That's what we have all right. So what's the important part? What do we really care about? Well, this trade-off is governed by the price ratio. So if you remember that, that's the least we need to know, right? If you're on the budget line, the rate at which you're able to move from one bundle to another, as determined by the market, is given by the price ratio. The price ratio is P1 divided by P2. Price of good 1 divided by the price of good 2. And I say this is the rate at which the market is willing to substitute one good for the other. Right? We haven't said anything about what the consumer wants. All we said is that we said they wanted more of one good and they have to give up some of the other. We haven't said anything about preferences yet. We're going to get to that over here. So far, this is just what the market will allow. Okay, so here's my Paradise Bakery example. So before I go any further, let's try a concrete example. So suppose I go to Paradise Bakery with $10 to spend on cookies and coffee. We'll assume the price of cookies is $1 and the price of coffee is $2. So assume x1 is the quantity of cookies and x2 is defined as the number of cups of coffee. My budget constraint, therefore, is just going to be P1 times X1. P1 was 1, so it's just X1 plus P2, which is 2, times X2 has to be less than or equal to the $10 I have available, right? So affordable purchases are those combinations of cookies and coffee that are costing me less than $10. And then I can afford all bundles that satisfy this inequality. Okay, so my budget line is given by that equation when it holds with equality. So X1 plus 2x2 is equal to 10. Now, suppose I spend all my money on coffee, which is good too. If I'm spending all my money on coffee, right, so my $10 divided by the $2 per cup tells me I can buy 5 cups and no cookies. If I spend all my money on cookies, the price is $1, I can buy 10. Right? So these extremes correspond to the bundles 0, 5, and 10, 0. And I'm checking this because I remember there was an error in the slide originally. I want to make sure this is right. So yeah, so 0, 5 is going to be our vertical intercept and 10, 0 is going to be our horizontal intercept. Okay, so even if we consider only the discrete goods, and there's many other bundles on the budget line that we could consume. So 2 and 4, 4 and 3, 6 and 2, 8 and 1 are all points that satisfy this equation. Now, typically, we're just going to assume that for convenience, goods are infinitely divisible, just like how we justified the smooth demand curve. Anyway, here's our illustration. My budget line, if the price of cookies is 1 and I have $10 available, I can buy 10 cookies. So M over P1 is 10. If the price of coffee is $2 and I have $10, I can buy 5 cups of coffee. Okay, so in my budget line, the price ratio is the price of cookies divided by the price of coffee, right? P1 divided by P2, so our slope is minus 1/2. Right. So as I mentioned, there's trade-offs between the goods we're consuming when you're on the budget line. So the slope of the budget line gives us the rate at which the market's willing to substitute good 1 for good 2. Now let's illustrate this. Suppose I'm currently at the bundle where I spend all my money on coffee. So 0, 5. Now if I want to stay on the budget line, but I want to buy some cookies, I'm going to have to give up some coffee. And you'll notice each coffee cup costs $2. So if I give up 1 coffee, I've now got $2, which I can use to buy 2 cookies because cookies cost $1 each. So if I give up a cup of coffee, I'll now have $2 available to allocate for 2 cookies. So my new consumption bundle would be 2, 4, right? So I lose 1 coffee. That gives me $2 that I can spend on cookies, which each cost $1. So my new consumption bundle, I'm moving down my budget constraint. It's going to be 2, 4. So the change in my consumption of coffee was minus 1. The change in my consumption of cookies was positive 2. So the price ratio is the change in good 2 divided by the change in good 1, or that's equal to the negative of the price ratio, which is minus 1/2. So this is just, working into this example, illustrating and sort of justifying this relationship I'd had on a couple slides ago. All right, cool. So far, we have only talked about what the consumer can afford. We haven't said anything yet about what the consumer actually wants. We'll get to that when we talk about preferences and utility. So we'll get there soon, but first we have some additional observations to make. So one of the things I want to talk about is how the budget constraint can change, or the budget set can change. So let's consider changes to the budget set, and let's work to answer questions like, what happens if the price of coffee falls? What happens if the price of cookies falls? What if both fall? What if something changes the amount of money I have to spend? All right. Well, I should have made these arrows go the other way. I should have done something different. Here, what I'm doing is I'm saying, suppose I have $12 instead of $10. Right? If I have $12 instead of $10, Now I can buy an extra coffee, right? I have $2 more. That's worth what? That's how much the price of coffee is $2, so I can buy an extra cup. And I can now buy 2 more cookies with my additional $2 instead of $10. So basically what happens is if I have $2 more, we're going to have a parallel shift of my budget line. We're going to be able to, there's more bundles I can afford. Notice the original budget line is now inefficient, right? So what I previously would have been what I would have been just barely affording is now something that's no longer exhausting my budget, right? Because I can buy everything on this line, and that's only going to cost me $10. I have $2 left over. Right? If I buy one of these bundles on this line, now if I buy one of the bundles on this line, now I'm exhausting my now larger budget, $12. Okay. Suppose the price of cookies rises from $1 to $2. This is going to shift in the budget line, right? So be careful to think about the logic of what happens here. The price of cookies rises, cookies now more expensive. I have $10 divided by price of $2 per cookie. Now I can only buy 5 rather than 10, right? So as the prices rise, the budget constraint rotates inward. See, here's the point that's rotating around. It rotates inward. As the price falls, imagine if the price was originally $2 and fell to $1, then it would rotate outward. Okay. All right. So now we'll talk about preferences. So we've discussed budget constraints. So far, we've only talked about what the consumer can afford. We haven't said anything about what the consumer wants. So now we have to introduce preferences to be able to talk about what the consumer wants. Now for the next couple of slides here, I'm going to talk about all kinds of additional terminology. And usually my advice for microeconomics is you want to pay attention to everything in bold. Pay attention to all the definitions. Well, here you're going to want to have sort of a working understanding of these things. You know, the type of question that I would ask, and virtually anybody else teaching introductory level micro, wouldn't have much to do with these specific definitions. I want to go over them, I want to talk about them, because you need this, you need to have the underlying background to be able to understand what we're doing here. But this is kind of one place in the course where, you know, don't waste a lot of time thinking about, you know, writing out note cards specifically for these definitions. So, okay, so suppose we pick an arbitrary bundle. This is the amount of good 1 and the amount of good 2 that we've got. We say all the bundles weakly preferred to x1, x2 is the consumer's weakly preferred set. All right, what do we mean by weakly preferred? Well, this goes back to thinking about inequalities. So if we have a strict inequality, that's something like greater than or less than. Those are things that are definitely bigger, definitely smaller than whatever is the number we're talking about. So that's a sort of a strict statement. Holding with strict inequality are those that are definitely bigger or definitely smaller than what we're talking about. If we relax that consideration a little bit and we allow greater than or equal to, that's a weaker statement, because we're saying, if we're in the case of greater than or equal to, numbers that satisfy, or things that satisfy greater than or equal to, are those that are bigger than our reference point or that are the same, right? So it's a weaker statement. Weakly preferred works similar. Weakly preferred works similar. So weakly preferred is going to include all the bundles that we strictly prefer to this one we're talking about, and all those that we're exactly indifferent between, that are equally good. So weakly preferred bundles, the weakly preferred set, are going to include all the ones that are at least as good as this one we're talking about, and all the ones we like better. Now, all the bundles the consumer likes as good as x1, x2, no better, no less, all the ones we like the same as x1, x2, as this particular bundle, make up an indifference curve. So an indifference curve is going to collect all the bundles. It's going to be a line. It's going to collect all the bundles that the consumer doesn't tell the difference between in terms of how it makes them feel, in terms of their well-being. Indifference curves form the boundary to the weakly preferred set, right? So the weakly preferred set is going to be all those I like better and all those I like the same as the one I'm talking about here. And the boundary are going to be all the ones I'm exactly indifferent between. Those beyond the boundary are those that I like strictly better, and those on the other side of the boundary are those that I like less. So, All right, so here's the illustration. Indifference curves are going to be all the ones that I like as much as this particular bundle. So I'm completely indifferent between anything in this red line. Now my weakly preferred set is going to be all the bundles that are weakly preferred to x1, x2. Actually, probably should have made these arrows red because the weakly preferred set is going to include the indifference curve, as well as all the bundles to the northeast. Remember, when we're talking about indifference curves, better bundles are to the northeast, right? Better bundles are to the northeast. So, I'm partial to the southwest myself. I think the southwest is the best, but some people like the northeast. So, apart from geography, this is true for weakly preferred set and for indifference curves. Better bundles are to the northeast. Actually, worse bundles from the perspective of indifference curves are to the southwest. All right. Okay, so an indifference curve through a bundle consists of all the bundles that leave the consumer indifferent to the given bundle. And we allow a lot of different shapes of indifference curves, but we don't allow them to ever cross. So why? Well, if indifference curves cross, we have a problem. This actually violates property of transitivity that we assume for indifference curves. But I mean, we could just see this right here. So by definition of indifference curve, which is collecting all the bundles that I like as good as each other, this is saying, let's see, I like X as good as I like Y, and I like Y as good as much as I like Z. That's a problem because this part of the indifference curve, right, this indifference curve that X is on and that Y is on, I'm supposed to be perfectly indifferent between these bundles and all the ones over here, right? In particular, this portion of this indifference curve, I'm supposed to like as much as X. But that can't happen because this is lying to the northeast of Z, which tells me I have to like these better than Z. But if Z is as good as Y and that's as good as X, then we have a big problem. So, all right, so we need indifference curves never to cross. Okay, so some different shapes of indifference curves, and I'll talk about these to represent some interesting goods we've already talked about in the class, right? So we talked about perfect subs. Those are goods that you can use in place of each other, and perfect complements are goods that are used together. So perfect substitutes be things like Coke or Pepsi, maybe like one or the other. And perfect complements, remember, that's like left and right shoes, right? You use them together. Or hot dogs and hot dog buns, peanut butter and jelly, whatever. So two goods are perfect substitutes if the consumer will substitute one good for the other at a constant rate. So this constant rate could be 1-to-1, right? Could be a 1-to-1 substitution, doesn't have to be. But I mean, so some people will be really strict on this and say perfect subs means when it's exactly 1-to-1. Substitutes are when the rates, what I'll sort of hold to is that goods are substitutes if you're going to substitute for them at a constant rate, which implies that the indifference curves have to be a straight line. So this is downward sloping straight lines, right? They look a lot like budget constraints, but we draw a lot more of them. Two goods are perfect complements if they're always consumed together in fixed proportions. These are the L-shaped curves, right? So these are going to be like a 90-degree angle. Vertex occurs where the number of one good equals the number of good one equals the number of good two. Where you have the vertex is where you have the same amount of both goods, right? Increasing both quantities at the same time will move you to a higher indifference curve. If you only increase one of the quantities, that's not going to help you, right? So I'll show this graphically, but think about left and right shoes. This is my classroom example. Imagine I give you a whole bunch more right shoes. That's not going to make you any better off, right? You only have however many complete pairs as left shoes as you'd have, right? Fixed proportion doesn't have to be 1-to-1. Maybe it's 3-to-1, right? So you think about like a recipe for making cookies or something. You maybe use 2 cups of sugar and 1 cup of flour or whatever. It's an interesting ratio. But the basic idea is it doesn't have to be 1-to-1. What's important for perfect complements is you are consuming these in the same fixed proportions. Okay, so here's perfect subs. Perfect subs preferences are always going to be downward sloping straight lines. I've drawn 4. There's actually infinitely many, right? So indifference curves, there's infinitely many indifference curves parallel to any of these, right? So the idea is we're going to draw enough, probably 3 or 4, to be able to get a sense of what these things are doing. And ultimately, when we're getting to utility and choice, we're going to want to compare this to a budget constraint. Matter of fact, what we're going to do is compare slopes of indifference curves to the slopes of the budget constraint. Okay, and here's perfect complements. So these are L-shaped or 90-degree angle. So to get to a higher indifference curve, you have to get more of both goods. So you have to get more of good X and more of good Y, or more of good X1 and more of good X2, good 2 and good 1. So this would be like left shoes and right shoes. Suppose I give you a whole bunch more right shoes. You have the pair of shoes that you're wearing, and then I give you a whole bunch more right shoes. Your utility, your well-being is not improving, right? I'm just giving you a whole bunch more right shoes. In order to get better, I have to give you some left shoes too, right? So you have to have more of both, right? All right. Okay, so well-behaved preferences. Well-behaved preferences. The important thing that I want to stress is we've got some interesting shapes of indifference curves we can talk about. So, we can represent perfect subs, we can represent perfect complements. There's other consumption patterns we could see driven by different preference structures that consumers have. So one such is well-behaved preferences. You don't have to worry about the definition of well-behaved preferences. It's nice if you can kind of understand what's going on here and here. You don't need to worry about monotonicity or convexity. Our monotonicity assumption is our more or better assumption. Basically, more is better. This is like better bundles are up to the northeast when you have more of both goods. And then averages preferred to extremes says, other things equal, we would rather consume bundles that involve some of both goods rather than heavy on one good or the other. So the convexity assumption would strict convexity would rule out our perfect subs preferences. But basically, with well-behaved preferences, monotone preferences, we get something like this, right? So what's the important part? Well, if we get these sort of curved indifference curves, they're not going to touch the vertical axis or the horizontal axis, right? Better bundles are still to the northeast, worse bundles to the southwest. Okay. And then let's not worry about that. All right, so marginal rate of substitution. The marginal rate of substitution is going to be the rate at which the consumer's willing to substitute between give up one good to get more of the other. So we defined the price ratio, and this is the rate at which the market was willing to give up some of one good for more of the other. Well, marginal rate of substitution is similar, but it's working for the perspective of preferences. Basically, the least you need to know about marginal rate of substitution is two things. So two things that are important. One, marginal rate of substitution, or the MRS, right, governs the amount of good 2 that you have to give up when you get more of good 1, how much good 2 you're giving up to remain indifferent. It's the slope of the indifference curve. And ultimately, we're going to compare the MRS, the slope of the indifference curve, to the slope of the budget constraint. So, right, this is a measure of the rate at which the consumer is willing to substitute one good for the other. So now we're talking about preferences. Now we're talking about what the consumer wants with their trade-off. What we're doing is we're taking away a little of one good and replacing it with a little of the other good to keep them indifferent. So as these amounts become infinitesimally smaller, the change, think of this as a derivative, approaches the slope of the indifference curve. Right? Indifference curves typically have negative slopes. The slope of the MRS is often negative. The slope of the price ratio is going to be negative as well, and so these negative signs are going to cancel off. So sometimes I won't bother to write them. All right. So here's an indifference curve. Here's the rate of change. So this is just justifying that the slope of the indifference curve is going to be the MRS. So actually here I've drawn a line tangent to the indifference curve. And so, right, so for something that's not a perfectly straight line, the slope at that point is going to be represented by the line tangent to the curve at that point. So that'll make more sense with calculus. You don't have to worry about that. What do you need to worry about for the class? Slope of the indifference curve is the marginal rate of substitution. All right. So if you have diminishing marginal rate of substitution, this is where we get our convex or or well-behaved preferences, right? So what's the important concept here? Well, look, the slope changes going from A to B to C to D, right? So if I'm at point A and I go to point B, I have to give up what, 2 units? I have to give up two coffees to get an additional cookie. But if I'm down here and I want to go from C to D, I give up 1 coffee to get 2 cookies, right? So the amount that I'm willing to give up, changes depending on my current consumption, right? Okay, so diminishing marginal rate of substitution. Referring to the picture on the last slide, observe that the marginal rate of substitution varies along the curve. So intuitively, at point A, I have a lot of coffee. I'm going to trade some for some cookies. Point D, I have very little coffee, and I'm very reluctant to give up any for additional cookies, right? So here, I've got a lot of coffee. I'm willing to give up a lot of coffee to get some cookies. And down here, I don't have very much coffee, and I have a lot of cookies. So, you know, I'm not gonna want to give up. So I have very little coffee and reluctant to give up any more for additional cookies. You better give me a lot more cookies if I'm going to be giving up my precious coffee. Okay, so look closely at the following potential trades. Observe the marginal rate of substitution decreases as cookies increase, right? So as consumption bundles change, the marginal rate of substitution changes. So from going from A to B, giving up 2 coffee, I can be as happy replacing it with 1 cookie, so the MRS is 2. Going from 3-4 to 4-3, giving up 1 coffee, I can be just as happy replacing it with a cookie. So the marginal rate of substitution is 1. And then going from C to D, the marginal rate of substitution is 1/2. What's the important concept? Well, if you have convex preferences, if you have well-behaved preferences, you have this property of diminishing marginal returns, or diminishing marginal rate of substitution. So basically, the rate at which I'm willing to trade one for the other changes based on how much my current consumption is. Okay, so here's an exercise. It's an interesting one. So, Anne and Bob both consume only coffee and cookies. Both always choose to have some coffee and some cookies, and both have strictly convex preferences. However, Anne likes to have a great deal of coffee with a few cookies. Bob likes to have lots of cookies with a little coffee. Both face the same prices for both goods and have chosen bundles to maximize their utility subject to their budgets. What can we say? Bob's MRS is larger than Anne's. Anne's MRS is larger in absolute value than Bob's. Anne and Bob have same MRS. Their MRS depends on the income levels. We know it's not that, right? This MRS, we haven't said anything about income. Who has the largest MRS depends on income. Okay, so it's definitely not D and E, right? We know that already. All right. So how do we answer this? Let's see. So both have some coffee and some cookies. So we know we're not on the axis. We're not on the. We know we're not on one of the intercepts. We don't have an extreme bundle. Anne likes to have a lot of coffee and a few cookies. Bob likes to have a lot of cookies with a little coffee, but they face the same prices, and they've chosen bundles that maximize the utility subject to their budgets. Okay. Well, if they're going to face the same prices, then the price ratios are the same. And it turns out if they're going to be optimizing, they want to consume where their marginal rate of substitution is going to be equal to their price ratio. And by that principle, which I'll introduce in a little bit, we'll see that, well, if they face the same prices, and they're optimizing, then it must be the case that their marginal rate of substitution is equal, because what we're getting is Bob sets Bob's MRS equal to the price ratio, and Anne sets Anne's MRS equal to the price ratio. Price ratios are the same, so Anne's MRS equals Bob's MRS. Okay. All right. So typically, we haven't talked about optimization. Typically, I'll kind of lead into that before we pose this question, but yeah, here's the answer. Okay, so actually probably after I go over utility and choice, come back to this probably. Okay. All right, so indifference curves and utility functions. I'm going to kind of skip over this part. I didn't talk about this in class, and so let's not worry so much. About this. Basically, yeah, I'm not talking about this here. Okay, so basic idea, what we really care about is we can represent uh, preferences with a utility function. There's a variety of reasons why we need to do this. Most of them have to be with the have to deal with the fact that preferences themselves are a little bit intractable to work with, so we want to come up with a nice functional form that we can use to represent those preferences. It turns out that there's a lot of different functional forms you can use to represent a given preference structure. The important thing that we need to worry about is, well, so I won't get into all those details. The important thing we need to worry about is um, we're going to see basically one type of utility function, this one here, right? Um, this one's actually not as difficult to work with as it looks like, but we can get everything we need to do from this utility function for our class, right? So, all right. So all that matters to the consumer is the total amount they have. The utility is going to be the sum of consumption of good 1 plus the sum of good 2. And there's a general form, right? So this would be like a coefficient that sort of measures or weights how much I like the amount of good 1. And here's a coefficient that weights my feelings towards good 2. So A and B measure the value of goods x1 and x2 to the consumer. The slope of a typical indifference curve is just minus A over B, right? So you could think of this for a given utility level, the slope, we'd just solve this for, we'd solve this for x2, and we're going to get minus A over B. Right? These are going to be downward sloping straight lines. These are exactly going to be represented. We can represent this utility function with the same indifference curves that we'd seen previously as our perfect subs. Perfect complements are like left shoes and right shoes. These are when we consume these goods together. It's a general form. So this would be my utility is equal to the minimum of like the benefit I'm getting from x1 times the benefit I'm getting from x2, right? So this would be like, suppose x1 and x2 are left shoes and right shoes. This would be like my utility based on shoes is equal to whichever is smaller, the amount of left shoes I have or the amount of right shoes I have. Why smaller? Because whichever is smaller, the number of left shoes I have or the number of right shoes I have is going to govern the number of complete pairs I have, right? That's why it has to be minimum. Okay, so A and B are positive, indicate the proportions in which the goods are consumed. I'm not going to show us this, so we won't have to worry about that so much. And then there's another general form we could use for well-behaved preferences. This would be if you'd multiply x1 times x2, and then we've got these powers. This is what we call Cobb-Douglas preferences. They're an example of well-behaved preferences. They're actually kind of cool. There's a lot of neat things you can do with this. We won't worry about that. So, like I said, the utility function we're going to care about is ones like this. And what's the MRS of this thing? It's just A over B, right? The MRS, the slope of the indifference curve, is just A over B. So we saw that with a number of examples in class. Okay, so Cobb-Douglas preferences, right? So for different exponents, we get different shaped indifference. Well, not shaped. They're all going to be sort of well-behaved preferences. But anyhow, so all right. So we'll skip over this here, and what I'm doing here is I'm justifying how the link between marginal utilities and MRS. So remember a couple slides ago I showed this delta x2 divided by delta x1 is equal to p1 over p2. This is doing the exact same thing, only it's going to be like delta u or delta mu, change in utility, right? Change in utility of one good divided by the change in utility coming from the other good is equal to the slope of the indifference curve, right? So basically what this is doing is we're saying, interested in studying how consumers' utility changes when given more of one good while holding the consumption of the other good constant. So we want to find the marginal utility with respect to good x. This is going to be mux. So basically we're saying, how is my utility changing? How's the change in my utility happening through the change in my consumption of x? So this would be I have some amount of two goods, I get more of good one, and we can talk about how my overall well-being changes coming through X1. Or suppose I get more of both. Well, we could separate out that, and I am better off because more is better than less. So we could separate out the benefit I'm getting from good one from the benefit I'm getting from good two. That's all we need to worry about here. So let's not worry so much about this part here. I'll show this for a second so you can see it with the video. I didn't spend a whole lot of time developing this in class, so don't worry too much about it. It's interesting. You want to save this for the intermediate micro class, but you know, um, if you really want to understand what's going on here, this is sort of helpful to mathematically justify it. But um, you know, basically, I want to include this in the slide deck just because the book's not going to do a good enough job talking about like why is the MRS why is the MRS sort of a legitimate representation of the rate at which the consumer is willing to trade off one good for the other. Well, that's the justification. I just gave it to us. Anyway, basically what this boils down to is the change in consumption of y divided by the change in consumption of x is going to give us the ratio of how my utility changes, my well-being changes, coming through x and coming through y. So just like how we had delta x2 over delta x1 is equal to p1 over p2 for the slope of the price ratio, or the price ratio is the slope of the budget constraint, here we have the slope of the indifference curve is the MRS. So the MRS is equal to this, or the MRS is equal to marginal utility of x divided by marginal utility of y. Okay. All right, so I'll just show this quickly and then I'll come away. All right, so now we want to determine how much a consumer with a particular set of preferences is going to choose to consume. So we saw we can find the slope of the budget constraint, the price ratio, and that tells us how much the market is going to allow trading for one good for the other. We can find the slope of indifference curve. This is going to tell us how much the consumer is willing to trade of one good to get more of the other. And it turns out we can combine these, set them equal, and that'll give us the optimal bundle, right? So let's consider a consumer with well-behaved preferences and find the optimal choice. We're assuming more is preferred to less, so we can restrict attention to the bundles on the budget line. Consumer has well-behaved preferences, so averages are preferred to extremes, and so consuming all of one good is not optimal. So we'll start at a bundle that's definitely not optimal and move to one that is. All right, so suppose we're down here. We're consuming all x and no y. Given these indifference curves, this is not optimal, right? Because if I move along my budget line, this is when I exhaust my budget on good 2. This is when I exhaust my budget on good 1. If I exhaust my budget on good 1, if I move up my budget line, I'm crossing increasing indifference curves, right? And actually, I haven't drawn the best indifference curve, right? So I can do better. So better indifference curves lie to the northeast. So indifference curve 2 is better than indifference curve 1. Indifference curve 3 is better than indifference curve 2. But I can't afford anything on indifference curve 3. So I should have drawn like indifference curve 2.6 probably, right? And that would be the one tangent to this budget line. Anyway, the point is if I move up the budget constraint, I will get to better bundles. So start at the bottom right corner where we have all x and no y and move up along the budget constraint. As we rise, we cross higher and higher indifference curves. Beyond, we stop when we get to the indifference curve that just touches the budget line, right? So we get the one that's just exactly tangent. And beyond that point, any bundles that are preferred are also going to be unaffordable, right? So yeah, I like the bundles that are on indifference curve 3 better than indifference curve 2, but I can't afford them. So, okay, so the bundle is an optimal choice when the set of preferred bundles do not intersect the budget set. So I should have rewritten this better. What do we care about here? What we care about is that we found the optimal bundle when the slope of the budget constraint is equal to the MRS, the slope of the indifference curve. So here's the picture, right? So the slope when the budget line is the tangent line for the curve, then we found the optimal bundle. Okay. All right, so that's why we call this a tangency condition. In order for the tangency condition to hold, we have to be able to assume preferences are well behaved, monotone and strictly convex. If it doesn't hold, it does not hold where there's a corner solution or where there's kinked preferences, like the Leontief, like the right angles, perfect complements preferences. We won't. Why? Well, it's a right angle. It's a corner. Derivative is not going to exist at the corner. So okay. When preferences are not strictly convex, there can be more than one tangency. So if they, so in the case of perfect substitutes, where you have perfectly straight lines, the indifference curves are perfectly straight lines. What if that line is coincident with the budget line? What if it lies right on top of it? Well, in that case, everything along the budget line would be optimal. All right, so when we cannot use the tangency condition, we have to be a little bit clever and sometimes use pictures to help with the economic intuition. So that's why I show these. I'll show the pictures on the board. So, okay, no tangency if there's a kink. If there's a kink, no tangency if there's a kink, and more than one tangency. You could get this way, or if you had, perfect straight lines that lied one on top of the other. How do we find the optimal bundle? Set the MRS equal to the price ratio, right? And then I showed in class how you could manipulate this. Do a little bit of algebra, and you'll end up with getting MUX divided by PX and MUY divided by PY, right? So kind of cross multiply a little bit. So what do we want to do? We want to divide by PX and we want to multiply by MUY. And you end up getting MUX over PX equals MUY over PY, and that was our last dollar condition, or our bang for your buck rule. And so that was the other way, alternative way of writing this. Okay, so let's see. Well, yeah. So I didn't. Yeah. All right. So if you have perfect substitutes, we get a situation where the optimal bundle is going to be on one of the axes. One axis or the other. So what's going on here? Well, what you want to do is you want to compare the budget constraint to the indifference curves. And remember, you always want to consume the best bundle that you can afford. So you have to be on the budget line, but you want to find the point on the budget line that's crossed by the highest indifference curve. Now, if the indifference curves are steeper than the budget constraint, it's going to be an all X solution, right? Draw it out on your paper for yourself. Draw a budget line and then draw a bunch of steeper indifference curves. The highest indifference curve is going to cross the budget line at this point. You can imagine what would happen if the indifference curves were flatter than the budget constraint. Then the optimal point would be the all Y solution, or the all X2 solution, all good 2 solution. And then with perfect complements preferences, the optimal choice is right here. So the type of question I'd ask you about here would be a left shoes and right shoes question, and so you'd probably use your intuition to be able to solve that one. Okay, so let me put away these slides. Like I said, the slides go a little bit beyond what we care about. The idea is to give us some background in terms of consumer theory. So, all right, so here's how I introduced budget constraint. So here's our expenditure on good 1. Here's our expenditure on good 2. And here's our income, right? So the budget constraint, price of good 1 times x1 plus the price of good 2 times x2 is equal to the income we have available, right? So the expenditure on good 1 is this part, plus the expenditure on good 2 has to not exceed our money available. Okay, so here I illustrated on the board, I said the amount of, I have to move this a little bit. Well, that's not great. So, all right. So if you buy nothing, we're right here. If you spend all your money on good 2, you're here. If you spend all your money on good 1, you're here. Let's see. All the points on the budget line are exactly those I can exactly afford. The budget line itself can be represented like this. I'm never going to have you do this. The only reason why I showed you this is because this justifies that the slope of the budget constraint is indeed P1 over P2. That's the whole point of this equation, is to just justify that we can represent the slope of a budget constraint as the ratio of the prices. Okay, and here's the work for where that came from. So slope of the budget constraint, the price ratio, reports the rate the market allows trading off good 2 for good 1, right? Rate at which I'm able to give up good 2 to get more of good 1 as I go down the budget constraint. Okay, so the key intuition, moving from a bundle to another bundle along the budget constraint requires a trade-off. So you're giving up good 2 to get more of good 1. Price ratio minus P1 over P2 governs the rate at which the market permits that trade-off. That's the key intuition for budget constraints. With consumer theory more generally, the question is, how does a decision maker optimize given their constraints due to scarcity? So we need to know what they want, that's preferences. We need to know what they can afford, that's based on income and prices. Based on income and prices, that's the budget constraint. That's what we're doing with consumer theory. We're bringing together these two parts to answer a question. Here's perfect substitutes. So the slope is constant. I just gave us a whole bunch of indifference curves. This would be like Coke and Pepsi. And then here's where good 1 and good 2 are complements. So here's nested indifference curves. Right angle indifference curves. Oops, and I have to move this up a little bit. There we go. All right. Okay. So then the important thing is if we're trying to answer a perfect subs question, we have to compare the slope of the budget constraint to the slope of the indifference curves. It turns out if the indifference curves are steeper than the budget constraint, you'll consume all of good 1, and that is equivalent to this condition, where mu1 over p1 is bigger than mu2 over p2. Spend more on good 1 and less on good 2. And if the indifference curves are flatter than the budget constraint, then you consume all of good 2, right? That was this condition. So what this is really illustrating was our bang for your buck rule. This is saying, hey, look, if the amount of gain to my utility per the price is bigger for good 1, I should just spend more on good 1, right? Why would I spend more on good 2? No, I'm going to spend more on good 1 because I'm getting more per price, right? Per the expenditure. So spend more on good 1, less on good 2. If it's the other way around, if the benefit that I'm getting, remember MU is marginal utility. How is my well-being changing as I'm consuming another unit of that good? If my well-being is changing, if the change of my utility coming through good 2 is bigger per its price than for good 1, well, I should buy more of good 2. So the MRS, if you have 2 goods and must give up 1 unit of 1 good, how much of the other do you need to receive to be as well off as before? That's what this is saying. Okay. And then budget constraint was built from price of goods 1 and 2 and the money available. The most of good 1 I can afford is m over p1, where I don't buy any good 2. The most of good 2 I can afford is m over p2, and no good 1. The price ratio is the slope of the budget constraint. This is the trade-off the market permits, p1 over p2. Preferences, utility. This is complements, right angle indifference curves. Substitutes are downward sloping, and then well-behaved are these convex preferences. So the MRS is the slope of the indifference curve. The MRS is the ratio of the marginal utility, the marginal benefit coming through good 1, divided by the marginal utility of good 2, the marginal benefit of good 2. And this is how the consumer views the trade-off based on preferences. And then our last dollar principle for constrained optimization, the best preferred bundle subject to my budget is going to be where marginal utility of good 1 divided by the price of good 1 is equal to the marginal utility of good 2 divided by the price of good 2. Okay. All right. So this one was talking about considering a situation where I give you a utility function. So suppose my utility function, utility coming from good x and good y, is 2 times x plus 3y. Well, the MRS, remember, it was just if this is A and this is B, it's just A over B, so the MRS is 2/3. If the prices were, price of good X is 3 and price of good Y is 4, price ratio is 3/4. And look, here the price ratio is steeper than the indifference curve, right? Price ratio is bigger than the MRS, so the budget constraint is steeper than the indifference curves. That's this picture. And so we want to consume this bundle optimally. Why? Because of all the bundles I can afford, here's lower indifference curves And here's here's the highest indifference curve of all. It's right here. So this is an all y solution, and the amount that I'd consume in this situation was m over py. So I said I had $12 available, divided by the price of good y, which was 4. So I can consume 3. Okay. And the type of questions you want to be able to answer: which bundle is optimal, how much x, how much y. Here's another example. I don't know if I have the picture of these indifference curves, but suppose your utility function is 3 x plus 1y. This MRS would be 3, right? 3 divided by 1, MRS would be 3. This price ratio, px over py, would be 1/2. 3 is bigger than 1/2, so this would be a situation where the indifference curves are steeper than the budget constraint. You could draw the picture, draw steeper indifference curves. You could draw them to look like they have a slope of 3, I guess. And then draw indifference curves that look like they have a slope of 1/2. Well, steeper indifference curves and a flatter budget constraint is going to be an all x solution. That's going to be the opposite picture of this one. That's going to be the one where down here would be the solution. Okay. Okay. Oh, indeed, I have that picture. Cool. So that's this right here. This is that picture I was just telling you to draw. Awesome. Okay. And I'm trying to figure out what I'm doing here. I'll just leave that for a second. Well, if my preferences are 2x over 2x 2x plus 3y, this would be MRS of 2/3. This would be a budget constraint with a slope of 3/4. 3/4 is bigger than 2/3, so this would be a steeper budget constraint. So flatter indifference curves. This would be an all y solution. How much do prices need to change before I switch to all x? Oh, that was kind of a good question. This got cut off. Sorry, I won't be able to do this one. Got cut off, so I won't be able to do it. But that's actually an interesting question. So suppose we have one of these. Question would be, how much does prices have to change before I switch my consumption to the other bundle? So you can think about that.